All right, fifth graders, we're going to get started on our week 2 bell ringers. So the first thing we're doing on Monday is an order of operations problem. So remember, we have please excuse my dear Aunt Sally, which is just stands for parentheses, exponents, multiplication and division starting from left to right, and then addition and subtraction going from left to right. So the first thing we have to do in this problem is our parentheses, which is just adding. 2 plus 3 is 5. So I like to copy everything else down. So now I just have 15 divided by 5, which is 3. We have a new problem, 12 minus parentheses 2 times 5. We have to do what's in parentheses first. 2 times 5 is 10. Now I have a new problem, 12 minus 10, which is 2. I'm going to come down here, write this number in standard form, 40 plus 3/10 plus 6/100. We've been working with place value, so we know we have 40 with a decimal point right there. 3/10, our decimal point is given to us right there. I'm just going to go ahead and fill in my 0 right there. And then 6/100, I have a 0 in my whole number. So I'm going to go ahead and fill in my zeros because I know that 30/100 is the same thing as 3/10. So I'm just going to add all these up. Some of you are probably thinking to yourself, well, I didn't need to add them up. And you're right. You really didn't need to add them up because we know the value of our place value. So it is 40 and 36/100. Remember, you only say the place value of your last digit. We'll talk about that more in class when we get to that unit. All right, next up, let's scoot my paper over a little bit, is an adding fractions problem. I have 1/3 plus 1/6. So I know that 3 can go into 6, and I already have 6 as a denominator. So I'm just going to bring my 1/6 down here, but I'm going to change my 3 to be a 6. So to do that, I'm going to multiply my denominator 3 by 2 because that's what I would need to do to get it to be a 6. Whatever I do to my denominator, I have to do to my numerator. So 1 times 2 is 2. So now I'm going to go ahead and add. That's what it's telling me to do here. So 2 plus 1 is 3. I do not do anything to my denominators. They stay the same when we're adding or subtracting. So my denominator is a 6. So 3/6 is the same thing as 1/2 because we know to reduce fractions, we would divide both our numerator and our denominator by the same thing. 3 divided by 3 is 1. 6 divided by 3 is 2. And our last problem for Monday says, if 2 people share half of a pizza equally, how much will each person have? And our answer here, the way we have to do this is if we have half of a pizza, remember I like to draw sometimes. I know some of you all told me you like to do the same thing. I'm going to take my whole pizza, but I'm really only going to have half of it. So I'm going to kind of get rid of this. We're not doing this. We're just looking at this half of a pizza. And I'm thinking about 2 people. So I really have to cut that pizza, that half of a pizza, in half. But to really think about how we're going to get this answer, I have to look at the whole part of the pizza. And I see that I would split this up into 4. So I see that I have 1 out of the 4 pieces here. So 1 out of 4, 1 out of 4, 1 out of 4, 1 out of 4. So if 2 people are sharing this, then one of those persons eating the pizza would get 1/4 of my pizza. All right, guys, we are ready for Tuesday of our week 2 bell ringers. Does that make you feel like you're at school? And it says to write an expression for this statement. Subtract 1 from 6, then multiply by 2. So to be able to subtract before we multiply, remember according to our order of operations, we would have to put this in parentheses. And if I'm subtracting from 6, then that means my 6 has to come first. It's kind of like a play on words. So I would have 6 minus 1 because I'm taking 1 away from 6. So I'm putting my 6 first. Then I'm multiplying by 2. All right, right here, round each number to the nearest whole. So remember what we did last week. I underlined my whole number, and I looked to the right. Oop, it doesn't look like a very good arrow. And I said 5 or more, raise the score. 4 or less, let it rest. Hopefully you guys did that with me while I was doing it. And I see that this is just a 4 or less, so I'm going to keep that 6 a 6. All right, now I'm going to underline my whole number here, which is actually a 0. I'm looking over to the right. Is it 5 or more? Raise the score, or 4 or less? Let it rest. It is a 5 or more, so that's going to bump this number here up to a 1. Our next problem says, in the backyard, Jennifer pulled half of the weeds and Roger pulled 3/8 of the weeds. What fraction of the weeds were pulled in all? And we talked about this phrasing in all, and that typically means that we are going to add. So we're going to add 1/2 and 3/8. And same thing as we did on Monday, we have to change the denominators. And I see very easily that 2 can be turned into an 8. So that way I could just leave this fraction alone. I love it when I don't have to do anything to both of my fractions. Because when we're adding fractions, we have to have a common denominator. So I'm going to leave this fraction the same. I'm just going to move over here so I have a little bit more room. So I'm going to leave my 3/8 the same, but I'm going to turn this 1/2 into something over 8. So to turn this 2 into an 8, I would have to multiply it by 4. So what I'm going to do to my denominator, I have to also do to my numerator. So 1 times 4 gives me 4. So now I'm adding my numerators. 4 plus 3 gives me 7, and I don't add my denominators. They stay the same. So my denominator is going to be an 8. So in all, they pulled 7/8 of the weeds. All right, our last problem is all about the metric system. We will learn about that a lot, probably in the spring. So I have 6,000 meters, and I have to figure out how many kilometers or kilometers we have. And remember we talked about this word kilo means 1,000. So because we already have our thousands here, we're just going to give this a 6 because we already have our thousands here. So whenever we're talking about meters and kilometers, we're taking out that we're dividing by 1,000. All right, so we have 7 liters here. And how many milliliters do we have over here? And we have 7,000. All right, it's the end of Tuesday. All right, guys, we're on Wednesday. Remember, this was our function table. Over here, we have what's going on with Captain America. Remember, here's where he goes in scrawny and he comes out looking like Captain America. So if I go in a 1 and my rule says add 5, I'm going to come out looking like a 6. If I go into my function table as a 2, I'm adding 5, I'm coming out looking like a 7. I go in a 3, I add 5, I come out looking like an 8. My last one, I go in a 4, add 5, coming out looking like a 9. I'm going to change pen colors so that helps you a little bit. Our new rule says subtract 2, so we have to really pay attention to our rules. I go in a 2, subtract 2, I get 0. 3, subtract 2, 1. 4, subtract 2, 2. Our last one, 5, subtract 2, is a 3. Here's where we're creating our ordered pairs. Remember, we have our x value, our y value, and our x's and our y's are over here. I should have used pink over here, sorry. Okay, so we're just putting them together. So I have 1 and 6, 2 and 7, 3 and 8, And last but not least, 4 and 9. Over here on this side, we have the same thing, our x and our y. I have 2, 0, 3, 1, 4, 2, and 5, 3. So now is usually your all's favorite part when you get to put it all together and put it on the graph. Remember, our first number tells us where to go going to the right. Our second number, our y coordinate, tells us where to go up. Okay, so our first number is, we always start at the origin. We go over 1 and we're going up 6. 1, 2, 3, 4, 5, 6. Our second number is go over 2. Now we go up 7. Our third one, go over 3 and up 8. And by this point you should be able to see a pattern, because it should always form a line, because these are a function, meaning they will form a line. If they don't, go back to your graph, your function table, and figure out what's going on. And remember, we always like to write the rule, add 5, over here on our line. That way we know what it looks like. All right, over here might get a little confusing to you because we have a 0. So I'm going to start out going to the right. So I'm going to go over 2, but our 0 tells us I'm not going to go up or down at all. So I'm going to stay right here on our x-axis. So now I'm going to go over 3 and up 1. I'm going to go over 4 and up 2. And last but not least, I'm going to go over 5 and up 3. I'm going to go ahead and connect those. I just like to have my line extend past my graph. And then I'm going to write subtract 2.